According to latest research, this is how Earth looked like 466 million years ago. Other terrestrial planets like Mars might also have had a ring. The ring had a significant influence on the global climate. An asteroid came within Earth's Roche limit and was torn apart by the tidal forces. The debris was spread out and the ring was formed. L-type chondrite with low iron abundance of less than 10% was found in sedimentary rocks. This is a diagram of age estimates of the currently recognized Ordovician impact spike craters, which occurred more frequently at this time. The blue curve shows the average global temperature prior to 1990. The continental plates were at a different position back then. For example, Antarctica was near the equator. The impact craters were within 30 degrees from the paleo-equator. 70% of Earth's continental crust was outside this region. The period with more frequent impacts lasted 40 million years and the ring slowly disappeared. The ring system had an impact on global climate. By blocking sunlight, it caused a global cooling effect. Due to the axial tilt of planet Earth relative to the Sun, the rings caused a shade of Earth's winter hemispheres. The reflected sunlight would slightly increase the solar flux to the summer hemispheres. Dust in the atmosphere could also contribute to a global cooling, the Hernantian glaciation period. 420 million years ago, the Hernantian glaciation ended. Alongside the impacts, volcanic aerosols, carbon dioxide, and the collapse of ice are possible causes. The Silurian-Devonian terrestrial revolution began. Plants and fungi colonized and thrived on dry lands. The oxygen concentration rose. Planet Earth turned into the species-rich planet we know. Today, planet Saturn has the most spectacular ring system. In 1610, Galileo Galilei became the first person to observe Saturn's rings, but he could not understand their nature. Due to the inclination of Saturn's rotation axis, the rings disappear sometimes when they are edged on from our point of view. The micrometers to meter-sized ring material consists of water ice with traces of rocky material. The innermost rings will disappear in the next 100 million years. The outermost rings will eventually fall onto Saturn too, but at a much longer timescale. Small shepherd satellites give the rings their substructure. Enceladus, with a size of 500 kilometers, is one of Saturn's 146 moons. The blue stripes in the southern hemisphere are geysers called tiger stripes. Ice particles that escape the plumes make up the E-ring of Saturn. The Cassini probe has detected a south polar subsurface ocean with liquid water. That makes Enceladus a world with potential for life. Jupiter's faint ring system has 4 components: the halo ring, the main ring, and the 2 gossamer rings. The large planets with their many moons can be seen as a mini version of the solar system. The rings are the equivalent of the asteroid belts in the solar system. Jupiter's rings were probably formed together with the giant planet. This image of the 13 rings of Uranus was captured by the near-infrared camera of the James Webb Space Telescope. The ring system contains very little dust and consists mostly of large objects from 20 centimeters to 20 meters in diameter. The rings are very dark and less than 600 million years old. They could be the debris from a collision of moons. These are the rings of the ice giant Neptune captured by the James Webb Space Telescope. The rings are named after astronomers who contributed important science on the planet: Gall, Leverrier, Lassell, Arago, and Adams. Like Uranus, Neptune's rings are very dark. They could contain complex organic compounds. With a diameter of 2,700 kilometers, Triton is the largest moon of Neptune. Triton could be a captured dwarf planet and orbits Neptune in a retrograde orbit. 3.6 billion years from now, Triton will enter Neptune's Roche limit and will explode. Neptune will have an extensive and complex ring system like Saturn. This is an artist's impression of ringed dwarf planet Quaoar. It has a size of 1,090 kilometers and is located at a distance of 44 astronomical units from the Sun. Its moon Weywot has a size of 170 kilometers. Quaoar has a system of 2 rings, the inner ring Q2R and the outer ring Q1R. Both rings are outside Quaoar's Roche limit. The moon Weywot orbits Quaoar at a distance of 13,300 kilometers. This is the picture from the discovery of Quaoar in 2002. There are 2 proposed missions for the exploration of the dwarf planet: the American Interstellar Probe and the Chinese Shenzhou Probe. Interesting objects of research are the methane atmosphere, geological features like cryovolcanoes, and the conditions in the outer heliosphere. There are still many secrets in the solar system waiting to be discovered. You can check out the links to the scientific article in the description field, and you can check out my other videos about the solar system. Thank you for watching. Bye bye.